Here I am again with the Empire 12-inch combination square. The last video that I did about this was checking squareness against this Precision Ground Machinist cube. And while some would argue that what I was doing was actually checking parallel with the surface plate, that is true. I was also checking squareness against the Precision Ground Machinist cube. So in this video, we're going to just not use this, and we're going to check the blade to see how straight it is. Now, I've already taken time to set 0 points at each end of the blade, and I have a single point of contact here. Now, I'm going to zoom in on this so you can see this a little bit better. Okay, so this is the single point of contact that the blade is resting on. And I'm not quite sure if you can see that, but this says LS Starrett. This is actually a gauge for a micrometer. So this has been precision lapped, or precision ground and lapped, however you want to put it. Anyway, it is extremely precise. And it is the single point of contact on which the blade is sitting. Now, the reason why I'm using a single point of contact here is because if I had the blade resting on something here or here, the difference in those two could be enough to throw this out of whack from end to end. So using a single point of contact, I'm reducing any kind of error that could occur like this. So it doesn't throw the blade out this way or this way. Now, those of you that are machinists, quality assurance people, please let me know what your thoughts are about this setup. The goal here is to go incrementally, inch by inch, all the way down the length of the blade from one end to the other. I'm going to keep an eye on the dial indicator, and in this particular case, 0 is set right at about here, but you'll see that when I zoom in. So let's see how it turns out. Now, I'm only going to feed the blade through in one direction. So what I'll do is I'll bring it up underneath the indicator, and you can see that that's reading 0. I'll bring it through and I'll bring it around and move it to the 1. And I'll do this for each inch increment. Okay, so that was from end to end. Okay, going back and looking at the video, it looks as though it may have dropped about a thou in this area right here. I'd say in between the 6 and the 9. it was minus 1/1000th of an inch. So it stands to reason that if I flip the blade 180 degrees, that it will be high in the same spot. Let's check that. Okay, so I've gone ahead and flipped the blade over 180 degrees, and as before, I've already zeroed it from end to end. Okay, so let's zoom in, and I'll repeat the process. All right, so again, that was from end to end. Now, from my perspective, it looks as though right between this area, it's a high spot of about 1/1000th, which is what I suspected when the blade was 180 degrees the other direction. Now, you guys watched it. You tell me what you think. Tell me if the setup was right. Tell me what you thought concerning the results. Am I seeing the same thing that you are? Are you seeing something different? You let me know. But as far as I'm concerned, I think that's pretty good. I mean, 1/1000th of an inch, that's pretty good for an inexpensive square like this. I know there's more testing that needs to be done, so I'll see you next time.